Hello everyone, welcome to the tutorial series of Python language quantitative trading practice. Let's continue to learn about the functions. In the previous lesson, we have learned about how to use the function strategy entry. Since there is an entry position, the strategy must be able to close the position. So there must be an exit function. So let's learn how to get the strategy position exit of the market today. What we will learn today is the function strategy close. Of course, it can be searched in our tutorial document, the Python language introductory tutorial of FMZ Quant. The function strategy close is mainly used for closing the position, that is, according to the ID we specified. In the last lesson, we talked about the function strategy entry. The parameter ID is a sign of entry. The position is closed based on this entry sign. So, how many parameters does the function strategy entry have? The main parameters are ID, when, quantity, and quantity percent. The parameter ID is the entry ID that needs to be closed. It's not the traditional ID, it's a class of ID that we named, such as long1, long2, long3, and so on. The class of ID is classified into the entry marker. So the parameter ID is the position we will close. To close a position based on a marker is the first parameter we passed in. The second parameter, when, is the execution condition that we want to specify to close the position. We can specify to close the position according to the fixed quantity, the parameter quantity, or the percentage of closing positions. For example, if the position is held for 10 contracts, then quantity percent is set to range from 0 to 100. If we set it to 10, that is, close 10% of the position. Suppose there are 10 contracts in the position at this time, that is, close 1 contract of the position. In order to learn the details of the function use, here we have written an example in the test tutorial specifically, and we can copy the complete code and test it in our backtest system. Save it. First, let's look at the trading rules. We specify the parameter scale in position, that is, the maximum position in the same direction with a number of increases of 3. Set the maximum number of scaling in position to 3, including opening the position for the first time. And here we set a global variable named enable stop, which is used to mark when to let the strategy throw an exception and then stop. If it's not set in this way, the strategy will keep trading and keep opening and closing positions. If we don't stop the strategy, it will output a lot of information in the log message column, which is not very easy to observe. So we will just let it do 1 round of opening and closing positions, and then let the strategy stop to make it easier to observe the roles of these opening and closing functions, and the results of the strategy operation. We set enable stop to true immediately. After we close the position, then the next round when we declare the variable enable stop. Since we declare it with var, indicating that this variable will not be initialized every time, and it will be recorded immediately after we make changes to it. So we let the enable stop to true. After executing the closing position, then the next time, before executing an open position, we determine if this marker is true. And if so, let it stop. So the above is the function of the code. First, we perform the entry operation, specify the entry order marker as long1. We can name this order identifier ID arbitrarily. Here we name it as long1. Then we specify the direction to go long. It is long entry, that is, the enumeration value of strategy long. Specify it as long entry. That is, then we specify the order volume as 0.2. That is, the trade volume is 0.2. Place a buy order of 0.2 contract or 0.2 spot, etc., depending on the market being traded. Then we judge it. Here we use a function strategy open trades, which we have never seen before. Of course, it can be searched in our FMZ Pine script document. We can see its number of market position entries which were not closed and remain opened. If there is no open market position, 0 will be returned. That is, there is no entry position at present. And the strategy open trades is 0. If there is an entry position at present, then the strategy open trades is 1. If there is 2 entry positions, then the strategy open trades is 2, and so on. Okay, we judge that if there is an entry position, we'll close the position. Here we set the strategy when the number of strategy open trades is greater or equal to 3. That is, when 3 entries are required, the marker of strategy long 1 is allowed to enter for 3 times, because this is the market price order. It will not pend, but it will be filled immediately. That is, the entry is made for 3 times. Actually, it's 0.2 volume of the entry for each time. Entry for 3 times long positions are accumulated to label long 1. And it's executed for 3 times. The position is 0.6. Here we can see that if strategy open trades is greater than or equal to 3, the execution of closing position was performed. There is no operation until it is greater than or equal to 3. It will keep making entries until the entry is made 3 times, and then it will close the position. At this time, if we specify to close the position long 1 only, without specifying the number of closing positions, how many positions will it close? And let's click backtest to try it out. Wait for a moment. Let's go back to the code page since it was reported an error just now. And here we can see this line of code is not right. We just forget to delete it. And now let's delete it to click backtest again. And here in the log message column, we can see that the chart shows long 1 has been entered for 3 times clearly because we are using the bar model. Here, the bar model. Each k-line bar was executed once, so we can see that the first k-line bar has been entered once. So we can see, and the second and the third k-line bar, the entry is a total of 3 times. Every one of them have the label of long 1. In the log message column, we can see that it entered for 3 times and then closed the position once. Since we want to specify the closing of long 1, we can see that this closing is the closing of all the entry orders of long 1. In other words, the accumulated long entry volume for the label long 1 is 0.6 in total. So let's go back to the code page. If we do not specify the number of closed positions for the close function, it will be closed all the positions. So let's try it. If we don't specify the ID parameter, and we click backtest to see, we click backtest to see if it will close this current position. And here in our log message column, we can see that it will also close all the current positions if we don't specify the ID parameter. This is where we need to pay attention to. What if we specify a non-exist ID? We can see that the entered ID are all long 1. The entered ID are all long 1 here. Without long 2. And let's click backtest to try it out. We can see it didn't close the position in the log message column. And we can see only 3 entries were made without any closing position operations, and the strategy was stopped. Let's go back to the code page. This line of long 2 was executed, but it has no effects because the strategy stopped. So it executed this line of code, enable stop. This line of code enables stop. But in the transaction just now, there was no closing of the position, which means that this line of code wasn't executed, but there was no operation effect. And let's continue our test. What if we specify the quantity of closing position? If I specify it, it will close 0.15 position only. And let's click backtest to try it out. We can see that after 3 entries, the actual entry quantity was 0.6, and then a close operation was executed, closing only 0.15 position. In the status column, we can see the entry order are all here. And no schedule orders. We closed 0.15 position only, and there left 0.45 position. That is to say, we buy the current position 0.45 more than the initial one. Let's go back to the code page. What if we specify the parameter quantity percent of closing 50% of the position? We click backtest to try it. And we can see the result is indeed 0.3 position in the log message column. That is closed 50%. And in the chart, we can see it was displayed in the chart since its bar model every K-line bar executed once. Let's go back to the code page. What if we close 80% of the position and it only close the position when close less than open? That is a negative line. Let's try it out. Click backtest. We can see that in the chart, it does not perform closing position. It does not perform closing position. It happens to be a negative line on the next K line, which fits this condition, so it closed the position. Let's go back to the code page. We change the condition to when closed more than open here. That is a positive line. We click backtest again. And we can see in the chart, it does not perform closing position. That is, when it reaches this K line, we need to judge the condition and close the position only when it is a positive line, not in a negative line. That is, if the condition of when close is more than open is not satisfied, it will not close the position. It also proves that when the function close is executed, the parameter when controls whether to close the position. When close less than open, it can close the position. When close more than open, it will not close the position. The test strategy shows the beginning of the 3 consecutive going long entry. The IDs of entry marker were all marked as long 1. And then use different parameter settings of strategy close function to close the position. The demonstration also tested out the different results of closing the position. We can find the strategy close function has no parameters. Here, strategy close function has no parameters, can be specified to place an order, which means the function uses the market price to close the position. That is, it does not specify a price to close the position. It does not plan to assign a price or condition to specify the closing price. It's based on the current price directly, that is, the immediate closing position and exit. The function is mainly used for this. In addition to the function strategy close, we also have a function that balances our positions, strategy close all. We can see the description of this function in our FMZ Pine script document. Here we can see strategy close all, and we also wrote an example. The function strategy close all is used to close all current positions, since the script in the Pine language has only one position direction. If a signal with the opposite position direction is triggered, it will close all current positions, and then open positions according to the opposite signal. Therefore, based on the mechanism, the Pine language can only have one position direction at the same time, so we use strategy close all is to close all positions in the current direction. Function strategy close all, which has only one execution condition parameter when. We can copy our test code and pass it into our test strategy for testing. First, let's take a look at the test code, which is similar to the test code just now. That is, That is, let it perform opposition opening operation in the opposite direction and then close all positions. In order to prevent it from closing positions repeatedly and printing too many logs, we set enable stop tag to stop the strategy. That is, if enable stop is judged to be true, the strategy will be stopped. Therefore, the process of implementing the strategy is to open a long position first. The open direction is set to long, that is buy, and the order quantity is 0.2. The condition is the positions. We can see that this is a newly learned built-in variable strategy position size. Strategy position size is used to record the quantity and direction of the current position. If it's a positive number, it means that the current position is a long position. If it's a negative number, it means that the current position is a short position. If it's 0, it means that there is no current position. The entry condition is that when the number of positions we hold is 0, that is, when we have no positions and when the close is greater than open, that is, when we are on the positive line, we can open the long position. The second entry condition is that the ID we set is short. That is, the label we set is short, and the direction is short, that is, the direction of selling. Then the order quantity here is 0.3, which is larger than 0.2. And the order direction also requires long positions, and it is negative. The order function of the reverse direction signal is executed. That is to say, when the strategy starts to run, if the first positive line is encountered and there is no position, we will open the long position. If we hold long positions and it's a negative line, execute the short signal in the opposite direction. This execution is 0.3 entries. We can see that we have started to enter 0.2 positions, which means that we have started to hold 0.2 long positions. When the reverse signal occurs, if the reverse signal exceeds the number, the mechanism of the Pine language will close all the current long position first, and then reverse to open the positions we want to open. If we don't write the code for closing positions, we can test it. In the log message column, we can see that it executed the long tag first. Let's go back to the code page. Long is a tag for going long and buy, and we execute the strategy entry function. And it should be performed when the K-line bar is positive. If the condition is met, the entry operation is performed. The entry quantity is 0.2. When the position quantity is 0 and the K-line bar is positive, the entry operation is 0.2. if the next K-line encounters a negative K-line. Here we can see in the chart this positive line has not triggered, and it has a reverse signal in the log. It has a reverse signal in the log message column. That is, the close tag is the short signal, then it will close the position first. And we can see that the ID tag that triggers the close position is short. That is, it happened a trigger of reverse signal after holding a long position, which closed the previous long position first. We can see it closed 0.2 previous long position and then open 0.3 position in the reverse direction. That is the order quantity of the short tag. So it can be seen that in the mechanism of the Pine language, when we hold a position in one direction, a signal trigger in the opposite direction occurs, which will close the position in the original direction first and then open the position in the opposite direction according to the trigger signal. And go back to the code page. We restore the closing position code. After we restored the closing position code, we click backtest again. And in the log message column, we can see that it has one more closing operation. Than the previous process, that is entering the long position first, then close the long position and open the short position. So then another closing operation, close all, is triggered. Close all the current short positions, that is, execute the operation of close all. Function strategy close has no function strategy close all has no parameter to specify the order price of closing the position. So the function strategy close all is the same as function close, which use the current market price to close the position directly. Next, let's move to a closing position function. Using the limit price to close the position, that is, the function strategy.exit. Again, we can find it in the Pine language introductory tutorial of FMZ Quant. It is used to close an entry position. Unlike this function, the strategy close and the strategy close all, they close position immediately at the current market price. The strategy exit function will close the position according to the parameter settings. So what are the specific parameters? The first parameter is ID, which is the current closeout condition order. Instead of the ID to close any of the position, the second parameter is from entry. It is used to specify the entry ID of the position to be closed. The parameter quantity is the number of closed positions. The parameter quantity percent is the percentage of closed positions. It ranges from 0 to 100. Then we can also set the profit target, that is, profit parameter. expressed in points here. That is what we talked about, the price per jump. If we set it to 50, close the position when the current 50 jump profit price is generated, and the stop loss target is also expressed in points. As for the parameters limit and stop, both of them need to be specified by the specific price. It can be interpreted as an exit schedule for strategy exit. We can see the parameters profit and loss, limit and stop are used to stop profit or loss, but the former pair is specified. The former pair specify the points. The latter pair specify the price. The last parameter is when, is the execution condition for exit. The condition must be true to perform the closing position order if the parameter when is set. Again, here we have written a strategy to understand these parameters. We copy them all and paste it to our code editing page. Save it. And let's look at the code. We set the parameter position increase model to 3 times. That is allowed to enter for 3 times. And the entry was made 3 times by using different IDs, long 1, long 2, and long 3. The 3 times of entry for strategy entry. And we also set different conditions for the entry, specify the price, specify the trading conditions. They are in the direction of long position entry. Then we judge when there is no execution. When there is no execution of the exit and the number of these transactions is greater than 0. Without closing the position or continuing to hold them, then the exit plan order is commissioned. After the plan order is commissioned, we set is exit to true so that commission will not be repeated. So here we set is exit. For the plan to exit is commissioned only once. That is entry for 3 orders, every order entry for 1 time. And here we set when equals to find order ID X. The custom function is actually used to limit the tag long 1. To entry for once, and similarly, long 2, long 3 to entry for once by using the function find order ID X. We let this strategy start with 3 different setups of entry tags, each with only 1 entry, and then execute the exit order plan. Once the exit orders are set, we set is exit to true. If it's not true, it will not entry repeatedly anymore. That is, all of these execute only once. As for the last line of code, it is used to print the current price points. If we specify it to close the position according to the points, what changes will the price have? Let's look at the custom function find order ID x. The custom function is to pass an ID in the order. In this code, all custom functions find order ID x call the admission identification ID. After passing in the ID, we first declare a local variable ret, that is -1. We first declare a local variable ret, which defaults to 1. If there are no current entry orders, that is, no positions are entered, the strategy open trees must be 0. At this point, we let the function find order ID x return to ret, that is -1. That is, no order has entered currently. If strategy open trees is not 0, that is, there is order entered currently, then we traverse the current strategy open trees. To see how many entry orders it has, we traverse the first one, use the function strategy open trees entry ID to get the specific ID. For example, there are 3 entry orders, 0, 1, 2. Then the index is 0, 1, 2. So we can judge the entry order with entry number of 0 and use the function strategy open trees ID to get the actual corresponding identifier, and then compares it with the identifier ID we passed in, that is, the long 1, long 2, long 3. We passed in to see whether it's equal. If it's equal, it means that we have found long 1 in all the entry long positions. If it's found, we assign the variable I to ret. And ret is not -1. We modify it, change it from -1 to I here. Then jump out and return to I. That is to say, the function actually checks whether there are currently long positions entered by the long 1 identifier. If so, it returns to its specific index. In the queue of entry, the first is 0 and the second is 1. If it cannot be found, the ret is -1. By default, if we can't find the equivalent in the for loop, the final returned position is -1. That is, when we return to -1, it means we can't find it. That is, when the function returns to -1, when it's less than 0. That is, when it is less than 0. It means that we can't find the long position with long 1 identifier in our current position. That is, it hasn't entered the market yet. Let it place an order and enter the market at this time. Therefore, the overall logic is to let long 1 enter only once. If it's found, it will not be executed. Otherwise, the function will be written in the global scope. If we have no condition restrictions, each time long 1 will perform an operation, it will execute strategy entry long 1. That is to say, the effect of this line of code is that the entry check is performed every time, but long 1 only enters once. Because we have set the parameter when, long 1 is only allowed to enter once, so are long 2, long 3. If there is a long position entry, the order will no longer enter. When open trees more than 0, it means that we have an entry order now, and then we will execute a corresponding exit operation. Then we click backtest. We can see that in the log message column, there are buying information. Normally, it should be 3 times, but actually there are only 2 buying operations. Why? Here we can see there are long 2 and long 3 in the actual purchase transaction. Why there are long 2 and long 3? Let's go back to the code page. Because we did not specify the limit parameter and other conditions for long 2 and long 3. That is, the long 2 identifier long position had not entered the market before, and we let it to perform an entry operation. The number of going long orders placed in the entry operation was 0.2. And we did not specify a price, that is, the transaction was made at the market price. Similarly, long 3 is also treated as a market price. So why didn't long 1 enter the market? Because the limit we set here is 1. The price is very, very low, and the order is hanging there. In the status column, here, we can see that the entry orders, the open orders are long 2 and long 3, while long 1 is in the schedule orders. Since we set the parameter limit to 1, and the quantity is 0.1, and this time it is impossible to deal the order, so that's why there is no long 1 entry in the log message column. Let's look at the corresponding closing position operation. We did execute the closing operation of long 1. And the first plan order of closing position is exit 1, which specifies to close the position of the order long 1. The condition is to close the position if there are 50 profit points. But why didn't it close the position? Because it haven't entered the market. In our FMZ Pine script document, there are some descriptions about the function strategy.exit. We can find function strategy.exit. It is a command to exit either a specific entry or whole market position if an order with the same ID is already pending. It is possible to modify the order if an entry order was not filled but an exit order is generated. the exit order will wait till entry order is filled, and then the exit order is placed. And in the status column, we can see both the entry order long 1 and exit order exit 1 are in the schedule orders. So that's the characteristic. If the entry order is pending, the exit order will not be executed. Next, let's look at the second exit order, exit 2. Then why do we have these identifiers? Because these exit orders, these plans commissioned can be cancelled. We use these identifiers exit 1, exit 2, and exit 3 to cancel the orders. The second identifier we named as exit 2, which is to close the entry order of long 2 and specify that only 0.1 positions will be closed. And it specified the profit to reach 100 points. In the log message column, the price per point is 1. Then the price for 100 points is 100. Close the position only when the 100 spread condition is met. So we can see that it executed the closing position operation. But the close the plan commission price is 20,236 because we set the bar model. It can only close the position after the K-line bar finished. The price of 20,236 was not in our expectation. And here we change it to tick model. Click backtest again. Wait for a moment. Here in the log message column, we can see the average price is 19,299 for the operation of long 2 entry. And the closing position operation for long 2 is the planned commission of exit 2. The price of closing position is 20,251. We can draw the conclusion that there is a profit of about 1 point in the closing position. So that's why we specify 100 points. Profit when we close the position of long 2. And the quantity of closing position is 0.1. And in the log message column, we can see it closed 0.1 of the position. Next, let's look at the third operation of closing position. We specify it to close 50%, and we add 1,000 at the end of it. Let's look at the description of a parameter limit in our FMZ Pine script document. The parameter limit is an optional parameter. Profit target requires a specific price. It closes the position according to the price, which is different from the parameter profit. Let's go back to the code page. We know here at the end of this line of code, we add 1000 to the opening position price and then close the position. In the log message column, the price of long 3 entry. The price of long 3 entry is 19,229, and the closing position price of long 3 exit is 20,252, and we can see it closed 0.15, and the identifier of closing position order is exit 3, and the identifier of closing long position is long 3, so it closed the long position of long 3, and the entry of long 3 is 19,299. The closed position is 20,252. It obtained a profit difference of 1000. It was not very accurate because we set the 1 hour K-line period here. The price tick will be large, but basically the profit of 1000 we set is guaranteed, and on the backtest result page, we also see the entry price plus 1000 is the price at which the position was closed. So this is the use of function strategy.exit. Of course, it also has more advantage uses such as trailing stop loss and stop profit, which are more complicated. If you are interested, you can use the strategy in our tutorial and set the parameters to have a test, and we will not to go further details here. So that's all for today's lesson. If you think our video tutorial is useful, don't forget to like, follow, and repost. Thank you all, and see you in the next video.